Imagine a version of Earth where humanity never turned its greatest inventions against itself. No world wars, no cold wars, no arms races, no hoarding of knowledge or wealth behind borders. Instead, imagine a single global civilization, flawed, imperfect, but unified, focused on one shared goal, improving the human condition. This is not a utopia. There is still conflict, disagreement, and hardship. But there is no large-scale war between nations. Let's explore where humanity might be today if, starting with the Industrial Revolution, we had chosen cooperation over competition. Each improvement, whether it's James Watt's separate condenser or Richard Trevithick's high-pressure engine, is immediately available to engineers everywhere. In our timeline, this power was unevenly distributed, concentrated in Europe, fueled by colonialism, and built on exploitation. In a cooperative world, the first major shift is education. Education becomes a shared investment, not a privilege. Literacy spreads rapidly. Basic engineering, mathematics, and scientific reasoning become universal skills, not because it's morally right, but because an educated population builds better machines, safer cities, and stronger societies. Think about what this means in practice. A textile worker in Manchester shares innovations with a craftsman in Bangalore. A metallurgist in Birmingham collaborates with an iron worker in Lagos. Knowledge is no longer trapped behind class or borders, it spreads freely, compounding innovation everywhere at once. Without colonial extraction, industrialization unfolds very differently. Africa develops manufacturing alongside agriculture. Imagine Ethiopian coffee plantations paired with processing facilities and machinery production. India becomes an engineering and industrial powerhouse earlier, with the expertise of traditional metalworkers in places like Kerala and Tamil Nadu merging with industrial-scale production. East Asia industrializes collaboratively, not defensively. Chinese silk production evolves into textile manufacturing, while Japanese craftsmanship scales to industrial precision. South America builds infrastructure instead of serving as an export colony. The copper mines of Chile feed electrical wire production. The rubber trees of Brazil supply industrial belts and seals for local factories. There is no developing world, only regions specializing based on geography and expertise. Now, many of the deadliest diseases of the 19th century were not inevitable. They were the result of overcrowded housing, contaminated water, and poor sanitation. In our timeline, London's Great Stink of 1858 finally forced the construction of a proper sewer system, but only after decades of cholera outbreaks killed tens of thousands. With shared knowledge, cities are planned instead of reacting to disaster. The principles that Dr. John Snow discovered tracing cholera to the Broad Street pump that contaminated water spreads disease become universal knowledge immediately. Clean water systems arrive earlier. Cities like Calcutta, Cairo, and Rio de Janeiro build separation between drinking water and waste from the very beginning. Sewage is treated as essential infrastructure, not an afterthought. Ventilation and spacing become standard. The overcrowded tenements that bred tuberculosis in New York and London never reach the same deadly density. Diseases like cholera, typhoid, and tuberculosis lose much of their lethality. Typhoid Mary never becomes a household name because typhoid never becomes endemic in the first place. With reduced childhood mortality, better nutrition, and cleaner cities, human life expectancy rises dramatically. By the mid-1800s, it's plausible that average life expectancy reaches 60 to 70 years, levels our world wouldn't see until much later. A child born in 1850 in this timeline has roughly the same chance of reaching adulthood as a child born in 1950 in ours. Medicine shifts early toward prevention, not crisis response. In our timeline, the late 19th and early 20th centuries were defined by rapid innovation, followed by catastrophic war. In this timeline, that innovation is never interrupted. War doesn't just kill people, it kills momentum. Brilliant minds are lost, research is buried or classified, entire fields are redirected toward destruction. Consider what we lost in our timeline. A generation of mathematicians, engineers, and scientists died in the trenches of World War I. Fritz Haber, one of the most brilliant chemists in history, spent his genius developing poison gas instead of focusing solely on his process for synthesizing ammonia, which fed billions. The Wright brothers' achievement of powered flight in 1903 led almost immediately to military aircraft. By 1914, planes were dropping bombs. Without war, physics advances without weaponization. Einstein's theories are explored for their implications about energy in the universe, not for building bombs. Aviation focuses on transport, not bombing. By the 1920s, in this timeline, passenger aircraft connect continents safely and affordably. The Hindenburg never explodes because hydrogen airships evolve slowly with safety as the priority, or are replaced by heavier-than-air craft designed for efficiency rather than speed, born from military competition. Computing emerges earlier through logistics and modeling. Charles Babbage's analytical engine actually gets built, not as a curiosity, but as a tool for coordinating global supply chains, calculating astronomical tables, and modeling weather patterns. By the 1890s, mechanical computers are handling census data, railway schedules, and industrial production planning. Ada Lovelace's vision of computers as more than just calculators becomes reality generations earlier. Scientists collaborate openly, building on each other's work instead of racing in isolation. Marie Curie's research on radioactivity doesn't happen in a cramped, underfunded Parisian shed. It's conducted in a well-equipped international laboratory where her findings are immediately shared with researchers in Tokyo, Moscow, and Chicago. In our world, unimaginable wealth was poured into weapons. The Manhattan Project alone cost over $2 billion in 1940s money, roughly $30 billion today. World War II's total cost, over $4 trillion in today's dollars. Here, those resources go toward electrification, transportation networks, healthcare, environmental engineering, and education. A medical breakthrough in Stockholm is practiced in Singapore within weeks, not decades. Fewer breakthroughs arrive suddenly, more arrive reliably. Rural electrification reaches every village by the 1920s, not the 1950s. Electric lighting, refrigeration, and powered machinery transform daily life everywhere simultaneously. Telegraph, telephone, and radio spread faster when no nation fears sharing them. Standards are unified. Instead of competing transmission systems and proprietary technologies, the world adopts shared protocols from the start. Alexander Graham Bell's telephone patents are freely licensed. Marconi's radio technology becomes a global standard immediately. Polio never paralyzes a generation of children. Without secrecy or nationalism, disease outbreaks are reported early. When influenza appears in 1918, there's no wartime censorship hiding its spread. Quarantines are coordinated globally. Vaccines are distributed everywhere. Remember, in our timeline, the Spanish flu killed somewhere between 50 and 100 million people, more than the war itself. Much of that death toll came from delayed response, poor coordination, and the movement of troops. Pandemics like the Spanish flu either never reach global scale or burn out rapidly. Disease becomes a shared enemy, not a political weapon. And cancer, not eradicated but understood much earlier. With shared genetic research, no patent hoarding, and global datasets, patterns emerge faster. By the 1950s, in this timeline, when our world was just beginning to understand DNA, researchers here have already mapped cancer's genetic triggers. Cancer becomes detectable earlier through blood tests, and imaging technology developed specifically for prevention. It becomes treatable earlier with targeted therapies instead of just surgery and hope. Cancer stops being a death sentence decades sooner. It becomes a chronic condition, manageable, often curable. This is where the timeline diverges most dramatically. Events like Unit 731, the horrific Japanese biological warfare program that killed thousands in grotesque experiments, required dehumanization, secrecy, and nationalist extremism. Without war, these conditions never align. The butterfly effect is enormous. Biology advances ethically. Instead of experimenting on prisoners, researchers study disease in controlled ethical environments with informed consent. Trust in science remains high. There's no Tuskegee experiment, no MKUltra, no legacy of medical atrocities poisoning public faith in research. Now, would nuclear weapons exist? Highly unlikely. Nuclear physics still develops. Rutherford still splits the atom. Fermi still achieves a controlled chain reaction. But energy, not annihilation, is the goal. The first nuclear reactor, built in the early 1940s, powers a city instead of proving a concept for a bomb. Reactors power cities by the 1950s. Research focuses on safety and efficiency, solving problems like waste disposal and meltdown prevention from the very beginning, not as afterthoughts. There is no incentive to build extinction-level weapons, and the physics is understood, but the engineering effort never happens. Imagine if the brilliance behind the Manhattan Project had instead designed fusion reactors. We might have virtually limitless clean energy by the 1970s. Financial downturns still occur, but they are managed globally. There is no war debt spiral. Nations aren't bankrupted by military spending. There's no economic isolation, no trade wars, no sanctions, no beggar-thy-neighbor policies. The Great Depression, if it happens at all, becomes a severe slowdown, not a global catastrophe. The Dust Bowl still devastates American farms, but international aid arrives immediately. Farmers are retrained, land is restored, and the social safety net that took our world a decade to build emerges in months. Without a space race, space exploration is slower, but more stable. There's no frantic competition to reach orbit, no cutting corners to beat the Soviets. Instead, the International Geophysical Year of 1957 doesn't end, it becomes permanent. By the 1960s, permanent orbiting stations exist, built carefully and collaboratively. Astronauts from every nation work together in laboratories orbiting Earth. Climate monitoring begins decades earlier. We understand carbon dioxide's warming effect not through scattered studies, but through systematic satellite observation starting in the 1960s. Astronomy advances beyond atmospheric limits. The Hubble Space Telescope launches in 1975, not 1990. Humanity understands Earth and space far better, far sooner. Now let's address the difficult question. What about racism, inequality, and slavery? These do not disappear, but they lose their structural power. Slavery historically depended on economic incentive, dehumanization, and enforced hierarchy. In a cooperative civilization, exploitation becomes inefficient. When education is universal, when industrial development is distributed, the cheap labor that slavery provided becomes obsolete faster. The cotton gin still reduces the need for hand labor, but without a plantation economy built on bondage, mechanization accelerates emancipation rather than entrenching servitude. Shared identity emerges earlier. When a Brazilian engineer, a Kenyan doctor, and a Chinese mathematician are colleagues working on the same global problems, the arbitrary lines of race and nation fade faster. Not immediately, prejudice remains deeply human, but inequality loses its scaffolding. The civil rights struggles that defined our 20th century happened differently here, earlier, with less violence because the economic systems that benefited from oppression never become entrenched. Fossil fuels are used briefly. Coal powers the first factories, oil fuels the first vehicles, but they're always understood as transitional. Cleaner energy matures earlier. Nuclear fission perfected in the 1950s, fusion achieved experimentally by the 1980s, hydroelectric dams built sustainably from the start, solar panels developed in the 1970s and mass-produced by the 1980s, wind turbines dotting landscapes by the 1990s. Entire economies never become dependent on extraction. The oil sheiks of the Persian Gulf never exist. The region's petroleum deposits are extracted cooperatively, efficiently, and briefly before the world moves on. Energy becomes infrastructure, not leverage. No energy crises, no petrostates, no oil wars. Mitigation begins before crisis. The modern container ship, which revolutionized global trade in the 1960s, arrives even earlier and runs on nuclear power or synthetic fuels. Logistics optimize for need, not profit. Food flows to where it's needed, not just where it's profitable. Waste collapses. The plastic pollution crisis never happens because material science advances toward biodegradability and recycling from the start. Abundance increases without destroying the planet. Climate change still exists, but it is detected earlier. Remember, Svante Arrhenius calculated greenhouse warming in 1896. In this timeline, his work is taken seriously immediately. The diseases of poverty, malnutrition, parasites, preventable infections are extinct. No runaway warming, no mass extinction trajectory. Coral reefs remain vibrant. Arctic ice stays frozen. The Maldives don't face submersion. Food, housing, and healthcare stop being luxuries. Vertical farms emerge in the 1990s, producing food in urban centers with minimal water and no pesticides. Desalination becomes cheap and efficient, turning coastal deserts into gardens. Housing is designed sustainably, modular, efficient, beautiful. Healthcare is preventative, regular checkups, genetic screening, early intervention. Work changes, fewer hours, more automation, creative and caregiving roles expand. By the equivalent of our 2020s, the standard work week is perhaps 20 hours. Robots handle manufacturing, agriculture, construction, and logistics. Humans focus on art, science, education, care for children and elderly, and innovation. Survival is no longer the primary job of most people. Instead of working to live, people work to create, to discover, to care for one another. Entire industries emerge in orbit. Zero-gravity manufacturing produces perfect ball bearings, flawless crystals, and pharmaceuticals impossible to create in gravity. Orbital construction builds massive structures piece by piece in the vacuum of space. Solar arrays kilometers across, telescopes with mirrors the size of cities. Space medicine discovers how the human body adapts to low gravity, extending healthy lifespan and treating conditions impossible to address on Earth. Satellite infrastructure becomes the backbone of civilization, communication, navigation, weather prediction, Earth observation, all managed from orbit. Careers exist that never required war to justify them. Thousands of people work in space not as soldiers or symbols, but as workers, scientists, and explorers. Asteroids contain rare earth metals, platinum, gold, rhodium, and vast raw resources like iron, nickel, and water. The first asteroid mining mission launches in the 2020s, returning more precious metals than all of human history combined. Scarcity collapses, the rare earth elements that bottleneck electronics production. Abundant. Environmental destruction slows, no need to tear apart mountains when you can harvest an asteroid. Economies shift from extraction to refinement, from scarcity-based capitalism to abundance-based cooperation. The moon becomes permanent, civilian, international. A research hub where lunar regolith is refined into building materials. A manufacturing node where low gravity enables construction impossible on Earth. A launch platform where spacecraft depart for Mars without fighting Earth's gravity well. No flags, no weapons, just science, industry, and human presence beyond our cradle. Mars exploration is careful and deliberate. The first crewed mission arrives in the 2040s, not racing against a rival, but equipped for long-term survival. Colonization is optional, not symbolic. Some choose to stay, building habitats beneath Martian soil, growing food in underground gardens, studying a planet that might once have harbored life. Space is not conquered, it is inhabited, respected, understood. With early space telescopes and observatories, we see farther, understand more, and contextualize humanity sooner. The James Webb Space Telescope launches in 2000, not 2021. By the 2020s, we've observed thousands of exoplanets, many potentially habitable. We've seen the cosmic web, the large-scale structure of the universe. We've detected gravitational waves, confirmed dark matter, and glimpsed the edge of the observable universe. The universe feels larger, and we feel smaller within it, humbled, curious, connected. Today, we stand at a similar moment. We have exponential technology, artificial intelligence that can diagnose disease, design molecules, and decode language. Global communication, anyone can speak to anyone, anywhere, instantly. Climate pressure, rising seas, extreme weather, ecosystem collapse, automation, robots that can build, transport, and create. Artificial intelligence, minds that think differently than ours, tools of enormous power. We can continue as violent territorial apes, hoarding resources, building walls, preparing for conflicts over water, rare metals, and habitable land. Or we can choose cooperation, not because it's idealistic, but because it's efficient. Because the challenges we face, climate change, pandemics, resource depletion, existential risks from technology, cannot be solved by any one nation. Because the tools we've built, the internet, satellites, genetic databases, artificial intelligence, work best when shared. Because we have, for the first time in history, the power to end scarcity, to heal the planet, to reach beyond Earth. So the question isn't whether this future is possible. The question is whether we choose it,